Hello, I'm Stefan Greber. I'm one of the maintainers for incus, and this is the release announcement for incus 0.3. So this release of incus came out a tiny bit late on a Sunday instead of a Friday. Not really any big deal there, just it being Thanksgiving week in the US, a bunch of things were a bit slower, so it took us a bit longer to have that come out. It's also a bit unusual in that it got released before a matching LexD release. Usually, or at least so far, incus has always released shortly after a LexD release. And this time we're actually releasing slightly ahead because LexD appears to be about a week late on their own release schedule for some reason. Anyways, this is not the most exciting release as far as like number of features or anything, mostly because on our side, I spent a week on a private trip, followed by a week at the Linux Plumbers Conference and Linux Kernel Summit in Richmond, Virginia, which was great because it was a good opportunity to go and catch up with quite a few people, including a number of the incus maintainers. The obvious downside is that because we were catching up in person, we didn't really get to do much work on incus itself. So that made it a bit of a lighter release. On the LexD side, it was also a lighter release for them because the canonical team was all meeting in person in Latvia. So kind of same deal on their side. That being said, there's still a very big feature in this release I'm super excited about, which is the OpenFGA support. So with that said, let's go through the new features. So as mentioned, the headliner is support for OpenFGA. OpenFGA, the FGA stands for Fine-Grained Access Control, and it's an open source authorization solution that lets you do pretty detailed access control. This needs to be coupled with something that knows what the user is. So in the case of incus, that means using OIDC, so OpenID Connect. And when the two are used together, then now every time a user wants to do some kind of action, the OpenFGA server is asked whether that action is allowed for that given user, and lets you do like pretty fine-grained, as the name implies, access control over the entirety of your incus deployment. The other nice thing with OpenFGA is that, well, it's a completely open source project, unlike Canonical RBAC, and this also does integrate with a number of other open source projects. I believe I've seen something about Kubernetes, for example. So you might be able to just run a single kind of policy server that handles a number of different projects interacting with it. So that's really exciting, really interesting. Configuring it is really straightforward. Once you do have the OpenFGA server up and running, you only need to configure a couple of keys, 3 keys to get things going. So you create a store inside of the OpenFGA server, you get that ID, and you also pass that along with a authentication token and a URL. And then the rest kind of just fills itself up. The model ID is actually optional and just gets configured automatically as the thing gets imported. There's some documentation on it as well to get a bit more details about like what different keys can be used as far as access control rules. And I guess the last thing to mention there is that this is a feature that originated on the LexD side. So that's work that the Lex team has been doing, and that got included in incus and tweaked a bit and tested a bit on our side. The main work we did was actually implement a full OIDC provider test server effectively, so that it's possible for the test suite to pretend to be any number of users over OIDC, and then test that with OpenFGA. So that was the main integration point there. Next feature is actually a number of improvements to lxd-to-incus. So lxd-to-incus is the migration tool that takes your LXD data and migrates it over to incus, as the name implies. We got a contribution to have support for OpenRC as an init system. So that's getting OpenRC supported alongside pre-existing systemd. And also a number of other tweaks around how to handle mounts. So one of the issues we had there is that like some people were already mounting some kind of disk on Valib incus, or had a disk mounted on varsnap lxd command lxd. And that was causing a bunch of issues because it wouldn't be detected and wouldn't be able to move the data properly. So now this is detected on both sides, either gets you an error if it's a scenario that can't be supported, or actually moves the amount for you and tells you that you need to go and update /etc/fs tab and those kind of files. So that's really taking care of a bunch of different bugs that we've seen reported since the last release. In this version of lxd-to-incus also now adds support for quite a couple of pretty major things that are needed for clusters. The first one is it knows how to migrate Ceph storage pools now. So Ceph, with Ceph storage pools, we use a marker volume that tells incus that this is a pool that was created by incus and that it can therefore use it. It's also used on startup to see whether Ceph is functional. That marker has had the name lexd in it, so now it needs to be renamed to incus. So we've got a migration step that takes care of that now. Another thing that needed a lot of migration logic is oven. So if you're using cluster with a bunch of oven networks, load balancers, and a bunch of different things there, every single object had a lexd prefix in its name, which was then replaced by incus in our code base, and so needed to go and be rewritten. So there's logic that effectively dumps the entire oven databases, so northbound, southbound, goes and replaces all of those prefixes, all of those entries, and then moves on to the rest of the migration. That's been working pretty well so far. I've got a couple of production clusters that I migrated that were both Ceph and oven based, and that's been working well enough. I've got one remaining cluster that I need to move over. For that one, I was waiting for actually incus 0.3 and OpenFGA. So hopefully in the next few days or next week or so, I'll get to migrate that last cluster. As the migration logic is becoming more and more complex, it becomes more and more useful to have a record of what's going on and how things were before. So that's why two new features were added there. One is to just keep a log of everything that's been done. That also includes every single command that's being run in the background, so any migration command is logged. And the other thing is actually making backups of data. So now the database is backed up, any kind of oven data is backed up as well. So it really does a couple of oven database backups ahead of the actual data migration, which means that if things go south, it's possible to go and at least go and revert some of the steps or figure out exactly what's going on so that the remaining steps can be done by hand. It's still a pretty tricky process. It works flawlessly on simple standalone systems like any kind of development systems, laptops, standalone servers. That should work really well. More complex servers, especially those that can't fully go down, where you do need to keep a machine up and running during the migration, those are still possible. There are a couple of hidden flags in lxd-to-incus that can be used to force its behavior in some ways. But that's where things can get pretty tricky. So anyway, if you've got anything too super advanced there, you may want to reach out either on the forum or directly to me, and we can look at that. Separately from this, my company actually does offer migration services for lxd-to-incus, especially for those kind of more complex cases where you may want to just contract to get a fixed fee one-time deal and just have it taken care for you, including any potential failures and data needed to be manually migrated and all that kind of stuff. The way I usually handle that is that anything that gets noticed gets immediately put into the tool so that nobody else ever hits that issue again. But it's effectively impossible to test every single combination and every single edge cases. So for very complex setup, it might be worth reaching out. And now the other, the last feature that was added is support for Hotplug, hot remove of paths in virtual machines. So you may be familiar with that, especially with containers, where it's super easy to just pass a path from the host system into the container. The same is true for virtual machines, but up until now, it's required restarting the virtual machine. That's now been fixed, so it's now possible to add and remove shared paths directly inside of a running virtual machine. And that needed a bunch of additional calls to QEMU and other places to actually get that pass through. And also interacting with the agent inside of the VM so that the path being passed gets automatically mounted. That works pretty well. There's some tiny edge cases around like what can you hot remove, because if something has support for 9p, we can't hot remove it. The Hotplug only does VirtualFS. We can't do 9p. That's just a limitation of QEMU effectively. We'd have liked to do both, but QMP that we use to reconfigure QEMU as when it's running doesn't support modifying FSDev devices, which is what's used by 9p. So maybe at some point that will become possible, or maybe 9p will just slowly fade away and we won't care anymore. Either way, this works fine with VirtualFS, which is what most people want to use anyways. And yeah, the other edge case is that whilst we can do the mount for you, that's safe, trying to unmount things on remove was deemed to not be particularly safe. Because who knows what string to write to it, who knows if they're like open files or anything. So unmounting is not done for you. So you need to go and make sure it's not in use before you actually hot remove it. Otherwise, you're gonna get an error. And that's pretty much it for the new features. Otherwise, we've got links to documentations, packages, the usual stuff. We're still waiting for, actually I need to fix the link, it's wrong, but I need to, the chocolatey package, for some reason, is still pending review on their side. I tried to reach out to the moderators a couple of times and nothing seems to be moving, so I need to look at that again. But until that's approved for Windows, you're gonna need to download the binaries directly from the release tag, which is fine, it works fine, but would have been nice to get chocolatey going. All right, so let's look at those features directly. I'm not going to do a demo of the lxd-to-incus stuff because it's effectively all bug fixes for pretty complex production environments, but I will demo the other two. So let's start with OpenFGA. All right, so here I've got a incus installation, which is running 0.3. It's not currently initialized. I'm just going to go through init real quick. I'm just going to pick default for everything. There we go. And now we want that to integrate with OIDC and OpenFGA. So let's do OIDC first. So to do that, I'm gonna need to go in my local keycloak server. So it's here. Okay, and what I'm gonna do is just go in the clients and create a new client in there. So just call it incus demo. Okay, so I'm just creating a new client inside of keycloak. And I'm going to authorize especially the OAuth2 device authorization grants that's needed by incus. So make sure that this is enabled, the rest we don't need, it's fine. Okay, so that gives me an OpenID client I can use. And let me just look up the full URL I was supposed to be using. It's in a different terminal. There we go. Oops. This one. Cool. Because keycloak doesn't make it super easy to figure out what the right option is for the OIDC issue or value. So in this case, it's that, and the OIDC client ID we said was incus_demo. Okay, so that's OIDC configured. We also need this incus installation to listen on the network. Okay. And now is the OpenFGA side. So I've got, oops, I got disconnected. Okay. All right, so I've got an OpenFGA server here, and that's how I'm gonna start it in this case. So it tells it to listen on port 8080 for the HTTP API, 8081 for gRPC. Authentication is gonna be performed through a pre-shared secret. And as we can see here, I'm disabling the playground, disabling the metrics server. So you run that, and now it shows that it's using memory as a storage engine, which obviously, I mean, it's fine for this purpose, but it's not persistent, so probably don't want to do that in production. For production, you'd use an actual database for that. Anyways, this is now up and running. So what I need to do is actually configure my system to use it. So I'm just gonna go look up the URL again for this guy. Okay. So the first thing you want to do is config set and then OpenFGA API URL, the URL to your server. So in my case, it's this guy. And then we want OpenFGA.api.key, I believe. For that, we're going to need to get the actual key from here. The pre-shared key is this guy. Okay. And then we need OpenFGA.store.id, I think. And that's going to be a store that we need to go and create. So let me see if I've got the right commands. I do. So this is using the FGA command line tool that comes with OpenFGA. You tell it to connect to, in this case, localhost, because I'm running that on the OpenFGA server itself, using the same token. And then store create, and we're going to create a new store. Let's call it incus_demo. Oops, it's -- name incus demo. And then we get that ID and set it as the store ID. OpenFGA. Okay, is it token instead of key? Yeah, it is. There. Cool. So now if we go look at the config, we can see that a model was created and automatically configured for us. And that's effectively it. All the authentication stuff is in place. So at this point, let's just try to add that server. If I get the IP address of my VM, incus remote add demo, and we're gonna do 122.17.250.186. Okay, and what happened here is it's prompting me to accept through OpenID Connect that this is all fine. So yes, device login successful. Now the remote has been added, and if we go look at it, we're gonna notice we've got access to absolutely nothing. So that's the difference compared to just bare OpenID Connect, where you would be able to see everything at this stage. In this case, we don't see anything yet. To fix that, we're gonna need to actually go and give ourselves some permissions. So let's see if I can remember how to do that now. Actually, it might be in my history. That would be convenient. See, it is in my history, hopefully. It is. Okay. So there are a few things we can do. Kind of the big hammer, and we can start with that. I think it's tuple create set. We'll say. So you do that. Then you do store ID, and the store ID is what we had configured earlier. So I just need to get it back. Okay. So we're telling OpenFGA set an authentication tuple for in this store ID for my user, which you can actually check. So you can check your own user here. It should be in my data somewhere. Let me just check. There we go. So the user showed here as auth username. So we can see this is the correct user. And in this case, we're going to give it admin on the entirety of the Incus server. And okay, it is not created to write. So just do write. Okay. And now let's see what we can do. Yep. Sure enough, we can see absolutely everything now. Now just for kicks, let's create a couple of projects. So project create foo bar. Okay. So as a full admin, I can still see everything. Now let's go and delete that access. Okay. And instead of admin, we're gonna do operator. And instead of the entirety of the server, we're gonna be restricting that to a given project. So we're gonna do project foo. Okay. And sure enough, we can only see foo now. And you can add a separate role for bar, at which point you can see both of them. There is more flexibility than that. I'm actually going to just show you the documentation again for that. Where is it? There. If you go to the documentation page, there's a bunch more kind of example for like what it does. Such as like server admin gets you full access to everything. So server support admin operator viewer. Projects can do manager operator viewer, and then you can also do per instance permission. So that's a new thing compared to what we had in the past with canonical RBAC. It's now possible to actually do per instance. And there are a bunch more tweaks. The exact model, so that's what's loaded inside of OpenFGA itself, is there, and actually lists kind of everything that's available that you can filter on. All right. So that's a very exciting development, very exciting tool. And what I showed just now with like giving operator to specific projects is effectively what I need to get parity with what I had with canonical RBAC in the LXD days, where you want to create a bunch of projects and you want to delegate those to specific users, not allowing them to see anything else. The operator access normally lets you create whatever you want inside the project. But it does not let you reconfigure the project itself, so you can't bypass project limits effectively. So that's the main reason for that level being kind of the go-to. All right. Next one is the sharing of paths. So I can actually do that right here. I do have that VM called demo that I've been using for the OpenFGA demo here. We can see that it's pretty simple VM. It's an Ubuntu 2204 VM. It's got 4 CPUs, 4 gigs of RAM. That's it. It doesn't pass any path or anything inside it, but we can change that. So let's add a new device. Let's call it home. Or let's call it etc. And we're gonna pass a disk. The source on the host is /etc, and I would like that to be mounted as /mnt/etc, and let's make it read-only for good measure. Oops, and I forgot to put the name of the instance, so it's the demo VM. Okay, here we go. So what that did is it effectively did a PCI Hotplug event to pass in the new shared drive. It also talked to the agent inside the VM to trigger this specific mount. We can see that VirtIO always marked it as read-write, but the read-only side is implemented on the host side, so it's still read-only at the end of the day. Now, if I was to just remove it as it is, it would not work very well, so I'm going to need to just unmount it. And then you can do config device remove demo, etc. And then it goes away. So that does let you dynamically pass in paths from the host into your VMs, which can be really, really convenient. Saves you a reboot, saves you from having to stop all the workloads inside of the VM. And that's it for Incus 0.3. You can go and play with it on the online demo. So that's always an option. You can just go start and play with it. For those who haven't seen that yet, we do have access to a web UI now that you can also use to go through things. And otherwise, packages are available. Currently, I've got them for Ubuntu and Debian in my repository. I believe I've seen that Arch and Gentoo, I think, are currently doing 0.3. A few other distros are going to follow up very shortly. If you want the clients for macOS or Windows, we've got the links here for Homebrew and the binaries directly for Windows. And if you want like to support any of the work or any of that, the details are in the description with links to Patreon, Ko-fi, GitHub sponsors, all that kind of stuff. And yeah, that's it for Incus 0.3. I'm really happy to see effectively this last well, at least for me, it was a blocker to migrate from LXD because anyone that was relying on role-based access control in LXD couldn't really migrate to Incus until OpenFGA landed, and now it's there. So now you can use an open source OpenID Connect stack with an open source authorization stack and get completely open source authentication and access control on incus for your either standalone systems or clusters. So very exciting day, very happy with that. And I'll see you in the next video. If you've got any questions, leave them down in the comment section below, or you can go in the community forum and enjoy incus 0.3. Bye.